Hi everyone, and welcome to another one of my videos. This booklet is for my new booklet number 16F that I've given you to work on over the Easter holidays. This help video is designed to give you some help if you're struggling with a few questions, especially if you're like me when I was your age and there's no one at home who can give you a hand. Now, I recommend that you try and do as much of this booklet on your own without any help using this video, and then use the video to help you with the questions that you're struggling with. Try not to use the video from the start. Do all you can without it and then use the video. It's not cheating. It's not cheating to use the video. That's why I've made the video for you. Now, as you can see from the icon, it's a non-calculator paper. So don't use a calculator on any of these questions. If you do, you're just cheating yourself, because you know you won't be able to use a calculator on any of these questions if something similar comes up in the real exam in the summer. If there are any questions that you can't answer without a calculator, please ask me to show you. I'm happy to show you. You know I'll always give you a hand. Okay, let's crack on and see how we get on with these questions.
Okay, question 1. That should be fairly easy. Just read it to yourself. 24,570. Okay, and write that to the nearest thousand, not to the nearest hundred. And then write it to the nearest hundred. Okay. The table shows part of a bus timetable. That should be fair enough. Another bus leaves Prudhoe at 8:28. Prudhoe at 8:28. Here it is. How many minutes should it take to get to Hexham? This is when it arrives. So how many minutes are between those? And I recommend you just count on. Okay, rather than try and do a subtraction, count on. 28 minutes to 30 minutes to 40 minutes to 45 minutes. Question 3, you should know these. That's fine. Start, that should be fine. Okay, when you write these numbers in order of size, the biggest number that is negative, okay, 8 is the biggest number, but it's negative, so it's the smallest number. So make sure you do that. Okay, don't go -1, -5, -8. Okay, these ones here, they should be fairly straightforward. Turn these into percentages and you're there. Question 5, whoopsie daisy. Question 5, 2x add 2x. How many x's have you got? How many x's have you got? When you add them together, how many x's do you have? 5y subtract 2y. How many y's have you got? If you take away 2, how many have you got? Simplify 2 times 4p. Okay, so what's 2 times 4? P. Okay, Ed spins a fair four-sided spinner once. The spinner can land on 3, or on 5, or on 7, or on 9. So make sure you understand that these are the numbers on the spinner. All right, it's not 1, 2, 3, 4. Okay, it's a four-sided spinner, but different numbers are on it. On the probability scale below, mark with a cross the probability the spinner will land on an odd number. Okay, how many numbers altogether and how many are odd? On the probability scale below, mark with a cross the probability that the spinner will land on 3. How many numbers are there altogether? How many are 3? What's your probability? Here is a pattern or sequence of patterns made from sticks. Work out the number of sticks needed to make pattern number 10. Well, work out what you're adding on each time. You're adding on the same amount and add that on to get to pattern number 10. Okay, you could do the nth term if you're feeling flash, and well done if you can do the nth term, but you're at pattern 3 here, and it won't take long to just add on the numbers carefully, making sure you don't make a mistake to pattern number 10. So with this question, it says, here are some ticket prices for entry to a museum. Adult ticket is 12, child ticket 7, senior ticket 8, family ticket, 2 adult tickets and 2 child tickets is £30. Seamus takes his family to the museum. He gets tickets for 2 adults, 3 children, 1 senior. Seamus pays the least possible amount of money for the tickets. He pays with 3 £20 notes. How much change should he get? Well, he could pay for 2 adults at 2 lots of 12, 3 children, 3 lots of 7, and a senior, 1 lot of 8. Work that out first of all. Or he could get a family ticket, which is probably going to save him money, but you've got to show that it does. And 2 of these adults and 2 of these children could get a family ticket and just pay £30, which would leave you having to pay for 1 more child ticket and the senior ticket. Okay, I reckon that will be cheaper, but it's probably a good idea to show that it's cheaper. And then you can work out the price, and then you can work out what the change will be from 3 lots of 20. Brian is making a fence. The fence will be 4 meters long. Brian uses 4 posts. Each post has a width of 10. Brian wants to have spaces of equal width between the posts. Work out the width of each space. You must show your working. You must show your working. So we've got some centimeters here and we've got meters here. So the first thing to do, I think, would be to change that into centimeters. So from here to here is, you know how many centimeters it is. Now the space, or this 4 meters, will be taken up by 1, 2, 3, 4 posts and 1, 2, 3 spaces. So work out what these posts add up to and take it away from what this is. What's left will be what the 3 spaces are, and then what you need to do to work out what 1 space is. Exactly. The diagram shows a flag drawn on a grid of squares. Colin says that 1/4 of the flag is shaded. Colin is right. Explain why. Well, you've got to find the area of this triangle. Now, what you shouldn't be doing is counting bits of squares and adding it up, because it's not accurate at all. You need to find the area of the triangle. Now, what's the formula for the area of a triangle? It's half base times height. So if you turn your head to 90 degrees, you can see that this is 90. I beg your pardon, this is the base, and this will be the height. Okay, base, height. Okay, so you've got the area of the triangle. Or what you could do is you could, if you cut this triangle here and cut this triangle here into 2 halves, this bit here that I'm outlining would fit in here. And then you've got the area of this rectangle here. And how would that help you? Okay, but you must explain why. So you've got to show what the area of this rectangle is here, and you've got to show the area of this triangle here and explain whether you think that is 1/4 of the whole area. What percentage of the flag is not shaded? Okay, well, you should be able to change fractions into percentages. If you know how much is shaded, then you know how much isn't shaded. And you should be able to change that fraction into a percentage. You might have to simplify it first of all, but you should be able to change it into a percentage. It's only got 1 mark, so I'm guessing that's fairly simple. Question 11. Write down the coordinates of the point A. Remember, go along and then up or down. On the grid, mark with a cross the point with coordinates 5, 2. Remember, go along and then up. On the grid, draw the line with equation y equals 3. So remember, we've spoken about that. That is all the points where the y number, the second number, will be 3. If you're not sure, plot a few points where the second number is 3. Like, for example, 1, 3, 5, 3. Once you've plotted a few points, you get an idea of what the line looks like. Which of these is the largest fraction? You must show clearly how you got your answer. Now, some people try to change this into percentages, which will work, but it's a bit tricky turning this into a percentage when you haven't got a calculator, because 40 doesn't go into 100. But look, these two numbers go into 40. So you could change this into a fraction with 40 on the bottom. How would you do that? And you can change this into a fraction with 40 on the bottom, 40 as a denominator. How would you do that? Once you've got the fractions with the same denominator, you can compare the numerators. So it doesn't matter what the denominator is as long as it's the same, because that then allows you to compare the numerators. So question 13 says, here are the ingredients needed to make 12 shortcakes. Liz makes some shortcakes and she uses 25 milliliters of milk. How many shortcakes does Liz make? Well, if she's using 25 milliliters of milk, the first thing to understand is she's not putting 25 milliliters of milk into this recipe. It's going to be far too wet if she did. She's scaled up all the ingredients and she's using 25 milliliters of milk. So you've got to work out how many shortcakes she could make. And probably the easiest way to do it is to think, okay, I've got 25 milliliters of milk. Okay, well 10 makes 12 shortcakes. So how many shortcakes could she make with 20 milliliters of milk? And how many shortcakes could she make with 5 milliliters of milk? And then you can put those answers together to get 25 milliliters of milk. Robert has 500 grams of sugar, 1,000 grams of butter, 1,000 grams of flour, 500 milliliters of milk. Work out the greatest number of shortcakes Robert can make. Well, if you've got 50 grams of sugar, you can make 12. So how many could you make with this sugar? This sugar is enough to make how many of these recipes? Can you see it's 10? You can make 10 of these recipes with 50. Okay, because 500 is 10 lots of 50. Do the same thing. Compare that with that. Compare that with that. Compare that with that. And then think about which answer are you going to take. Are you going to take the biggest answer from here or the smallest answer from here? Okay? And think about that. If, say, for example, you had enough of one ingredient to make 50 lots of these recipes, that's fine, but you won't be able to do that if you don't have 50 of all the other things. So think about when you've got these answers, okay, you've got enough sugar to make 10 of these recipes, but have you got enough butter to make 10 of these recipes? Have you got enough flour to make 10 of these recipes? Have you got enough milk to make 10 of these recipes? Okay, think about whether you're going to take the biggest number from here or the smallest. Ria is going to buy a caravan and the total cost of the caravan is £7,000 plus VAT at 20%. Ria pays a deposit of £3,000 and she pays the rest of the total cost in 6 equal monthly payments. Work out the amount of each monthly payment. So she's going to pay £7,000 plus VAT at 20%. And the first thing to understand is that you need to add on the 20% first before she pays the deposit. So she doesn't pay 20% on the 4,000 that is left after she's paid the deposit. You've got to work out 20% of this and add it on. That will tell you the total amount that she pays for the caravan. Then you can take off that because she pays that to start with. The deposit is okay, the upfront payment that you make. How much left will be left to pay? What that is will then be shared between 6 equal monthly payments. Buses to Acton leave a bus station every 24 minutes. Buses to Barton leave the same bus station every 20 minutes. A bus to Acton and a bus to Barton both leave the bus station at 9 o'clock. When will a bus to Acton and a bus to Barton next leave the bus station at the same time? Now, one way to do this would be to find the lowest common multiple of 24 and 20, and you could do prime factorizing, but probably the easiest way to do it is this. Okay, you've got buses to Acton leaving a bus station every 24 minutes. Okay, so buses to Acton are going to leave 24 minutes, 48 minutes, and another 24, 72 minutes, and so on. Okay, so you've got a list of all the times that the buses are going to leave from to Acton. Do the same thing to Barton in 20 minutes, 20, 40, 60, 80, and so on. Sooner or later, a number will appear in both lists. Okay, and that's how long you'll have to wait Okay, and then you can add that time onto 9 o'clock. Or you could say, okay, buses to Acton will be 9 o'clock, and then the next one will be 9:24, and the next one will be 9:48, and the next one will be, and the next one will be, and the next one will be, and so on. Okay, but that involves a bit more working out. It's a bit tougher that way. And same thing for this one. Okay, buses to Barton will leave at 9 o'clock, and then 9:20, 9:40, 10 o'clock, 10:20, 10:40, and so on. And sooner or later, like before, you'll get a number or a time that appears in both lists. I think that's the most simple way of doing it. The table shows the information about the number of grams of protein, of carbohydrate, and of fat in 100 grams of regular yogurt and in 100 grams of low-fat yogurt. Work out the number of grams of protein in 200 grams of regular yogurt. Well, in 100, you've got 4.7, so I'm sure you can work that out. And then you can draw a bar chart here, kind of giving the game away. It says draw a suitable diagram or chart. Okay, well, I've given you a graph here. What you're definitely not going to do is a line graph. It needs to be a bar graph. Okay, and the things to remember that drop marks are a nice scale along here, a scale along here, and you label it here. Okay, but 4 easy marks basically. Question 17, translate shape A by the vector -3, 2. Now a vector tells you how points move. It's a bit like a coordinate, but instead of telling you where something is, it tells you how something moves. -3, 2. The first number is the along number, and minus means it goes left. Okay, the second number is the up-down number. Okay, 2 means it goes up, -2 means it goes down. Just like this one here, -3 means it goes left, and 3 means it goes right. So you've got to move every single point by this amount. Okay, sometimes you can just move one and then see how the rest of them go, but it's probably simple just to move all of these points along 3 and up 2. Make sure you go along in the right direction, and then you've got your shape. Describe fully a single transformation that maps Q onto shape R. Okay, so you need to decide what transformation that is. Well, it's not a translation because it's leant over. So it's either a reflection or it's a rotation. If it's a reflection, you need to know where the mirror line is. If it's a rotation, you need to say three things. You need to say rotation, you need to say how much you're going to rotate it by, and don't forget to say clockwise or anti-clockwise, and you also need to give the center of rotation. That means where would you put your pen on the tracing paper so that when you turn the tracing paper, one shape goes onto the other. Also, be very careful if you think it's a rotation that you go from Q onto R. When I looked at this question, I immediately moved it from here to here. But actually look, it's saying from Q onto R. So we're going from here to here. If it is a rotation, okay, you've got to decide whether it's rotation or a reflection. Write down the value of 10 to the power of 0. Write down the value of 10 to the power of -2. Well, what you could do is remember, or first of all, remember what that negative does. It's like 10 squared, but it's got a negative. That negative just does something very, very simple. What is it? 10 to the power of 0. Any number to the power of 0 is a special number. It's a certain simple number. Okay? I'm not going to tell you what it is. Is it 0 or is it 1? But it's one of those two numbers. Now, just for the sake of you knowing how to do this on the question, on the paper, use a calculator here. And then try and do any other number to the power of 0. Okay? You should notice once again that you get the same answer every time. And now make sure that you remember what that same number is so that you don't have to use a calculator in any further questions. Any number to the power of 0 is a certain number, and it's always that number. Write these numbers in order of size. Start with the smallest number. Okay, So I think if I was you, I would change each of these into normal numbers first of all. Okay, remember what that means. 2 to the 27.3 times 10 to the power of minus 3, the decimal point is going to move this way 3 places. To the power of 3 means the decimal point moves this way 3 places. Write them out as normal numbers so that even if you make a mistake, you might pick up some marks. Once you've got them as normal numbers, it should be easy to put them in order, but make sure you start with the smallest number. Matthew puts 3 red counters and 5 blue counters in a bag, and he takes at random a counter from the bag. He writes down the colour of the counter, and he puts the counter in the bag again. He then takes at random a second counter from the bag. Complete the probability tree diagram. So this part of the tree diagram is for when he takes the first counter out of the bag. Reading this stuff here, if you know that the probability of getting red is 3 out of 8, you should be able to work out what the probability of blue is. And he puts the counter back in the bag again. So that's why it's 3 out of 8 for red here. This part of the tree diagram is for when he takes out the second counter. And you might look at that and say, why have I got red there and why have I got red there? Well, a tree diagram is just a way of setting out all the different ways that something can happen. So it's red here because you've got red on the first counter and then red on the second counter. It's red here, but you've got blue on the first counter and red on the second. So a tree diagram is just a good way of just writing out all the different things that can happen. Because if he's taking out 2 counters from the bag, what could they be? They could either be red, 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 blue, blue, then red, or blue, then blue. And so we've got the 4 different things that can happen. And you can work out the probability of 2 things happening by multiplying their individual probabilities. So if, say for example, we said when we flip a coin, what's the probability that we get tails twice? It's the probability of tails times the probability of tails, a half times a half, which is a quarter. So to find the probability of 2 things happening, you multiply the probability of each of those things together. All right? So what's the probability of him getting 2 red counters? Okay, what did I just say to do to these numbers here? And also I forgot completing the tree diagram. Well, you can work out what these are going to be. Okay, and then you pick up 2 lovely easy marks. On the grid, draw the graph of x plus y equals 4 for values of x from -2 to 5. So just a minute ago on the previous question, I said to you about the line y equals 3. It's the points where the y number equals 3. Once you understand what this equation is telling you, it's basically telling you how to draw the line. It's saying all the points where the x number and the y number add together to make 4. So what could they be? What 2 numbers? Okay, 2, 7. No, that won't work because 2 plus 7 makes 9, so it doesn't make 4. 1, 3. A coordinate, a point with the coordinate 1, 3. Here. That's on the line. Why? Because 1 and 3 make 4. Okay, the x number is 1, the y number is 3, x plus y is 4. Okay, what other points are there where the x number and the y number add to make 4? Plot them, and then you should find they're in a straight line. You join it up and make sure you extend your line from 5 to -2. Okay, so you might have some points here. Okay, extend the line backwards so that it goes up to here. Right, next question. The diagram shows the plan of a floor. The area of the floor is 138 square meters. Work out the value of x. So there's lots of different ways of doing this, and you could cut this into rectangles and that would work. Okay, but I think the simplest way here is to say, right, imagine this as a rectangle. See this rectangle here? With this rectangle cut out of it. Now, if this rectangle was the whole thing, right, what would this length be? You know that's 8. You've got another missing length somewhere else. What's this? Okay, so now you know what that is, and you know what that is. You can work out the area of this big rectangle. So if this bit wasn't missing, you've now got what the area would be. But you can see that it is missing, and the area is 138. So if you know what it is when this bit isn't missing, and you know what it is when it is missing, you can work out what the area is of this rectangle. And if 3 times x makes that answer, you can work out what the value of x is. PQRS is a square. All measurements are in centimeters. Show that the perimeter of the square is 10 centimeters. So basically what you need to do is work out what x is. If you know what x is, then you can work out what the sides are, and then you can show what the perimeter will be. Now, how could you get a value for x? Well, this is the key statement here. PQRS is a square. So if it's a square, what do you know about that and that? Right. So now, how would you write that as an equation? Okay, just writing that down as an equation will probably give you a mark. Look, you've got 4 marks for this. Once you've got that as an equation, solve that equation. Once you've got a value for x, you can work out what the sides will be. Okay, and hopefully you'll get the same answer here. Okay, and then you can add up to get your perimeter. Peter, Tarish and Ben share £54. Tarish gets 3 times as much money as Peter. Ben gets twice as much money as Tarish. How much money does Ben get? Well, probably the simplest way to do that would be to look at Peter. Well, Peter gets the smallest amount. So I'll just draw a little box there. Okay, and that's going to represent what Peter gets. And Tarish gets 3 times as much as Peter. So I'm going to draw 3 boxes for Tarish. And Ben gets twice as much money as Tarish. So how many boxes will I need to draw for Ben? I've got 1 box for Peter. I've got 3 boxes for Tarish because he gets 3 times as much. How many boxes would I have for Ben? And then I say to myself, right, what must all those boxes add up to make? Now I can work out, okay, that those boxes need to add up to make 54, so I can work out what each box is. And then, once I know what each box is, work out how much Tarish gets. Okay, you know how many boxes Ben gets from your diagram you've drawn here, and so you can work out how much money he actually gets, because you've just worked out what 1 box is. Question 24. Use ruler and compasses to construct the bisector of angle ABC. You must show all your construction lines. It's really, really, really important. Okay. Now the bisector cuts something in half. Okay. Now I'm going to sketch this very roughly using my mouse arrow in a minute, but I really recommend you look at something like My Maths or Corbett Maths or Maths Genie, something like that, or even look on YouTube and literally type into YouTube how to bisect an angle. Alright, but very briefly what you're going to do is this. Put your compass point here and open up your compass to about halfway along here, roughly halfway. You don't have to measure it. With your compass point here, draw part of a circle called an arc that's going to cut like this. Now, the 2 places that you're interested in are where it cuts this line and where it cuts this line. Alright? Put your compass point where that arc cut this line and draw another arc here. Put your compass point where that original arc cut this line. Put your compass point there, draw another arc. They should cross roughly here. Join that point where they cross to here, and you should get a line, okay, that cuts this angle in half. Okay, you know when you got it right or not because you'll be able to see that this angle and this angle will be the same. Now that didn't make sense because I couldn't actually literally draw it. As I say, just literally type into YouTube how to bisect the angle, okay, and it will show you. All right. Okay, I hope that video was helpful to you. And if it doesn't, then please ask me. Okay, cheers guys, thank you very much.